All right, in this video, we are going to learn about what's called our angle of elevation and depression. All right, so just to kind of touch on them real quick before I go over it, they are exactly as they sound. You have your angle of elevation. You are looking upward, okay? So think about like elevate, you're going up. And then your angle of depression, you are looking downward. Okay, so we have a few things to go over. We have now, suppose you are looking up at the airplane. The angle that's going to be formed by a horizontal line and your line of sight to that airplane is what we call the angle of elevation. Now, suppose you are standing on a cliff and you are looking downward at a river below. The line is going to stretch horizontally from your point of view on that cliff. Your angle of sight to the river is going to form what we call the angle of depression with the horizontal line. Okay, so I'm going to look over here at this picture. Let's talk about a few things. So once again, just going through and showing you, we have our angle of elevation is going to be here when I'm looking at this horizontal line. I'm then going to look upward from that. So I'm going to be forming this angle here. With the angle of depression, you're going to start from a high point. Okay, and so here's going to be my highest point up here in the top left corner. And I've got to first look straight across, having that horizontal line again, and then looking downward. Some key things to note is that your angle of depression is not going to be located inside of the triangle. But something to mention that's over here in this third paragraph, because we do have these horizontal lines, we've got two of them, they are parallel to each other. So that's why I drew those arrows there. When you have parallel lines being formed and you have alternate interior angles, so this angle here and this one down here, they are congruent. So a lot of times you'll see when I'm working through a problem like this and I'm labeling my picture, when they give me the angle of depression, I like to go ahead and just put it as my angle of elevation as well. All right, so I'm going to come over here and let's look and see what this last paragraph says, which is pretty much what I did mention. We have note that our angles of depression and elevation are going to be measured from the horizontal line. Also, because they are alternate interior angles on the parallel lines, we know from our previous unit that they are going to be congruent. All right, just a few reminders. We have our make sure that your calculator is in degree mode. That's going to be a very important one so that you can get the correct answer. And then our mnemonic device here, our memory tool, is going to be that SOHCAHTOA. Okay, so that's going to stand for our sine of theta. Our angle is equal to the opposite over hypotenuse. Our cosine of theta is equal to the adjacent over hypotenuse. And tangent of theta is equal to opposite over adjacent. All right. Lastly, before we jump into our problems, I've got a few steps that you are more than welcome to kind of use as you are working through these problems. And they are the steps that I do use, so you'll see me use them, solving them. Step 1 is draw a diagram. We're going to make a right triangle because this whole unit is over right triangles. Step 2, interpret the information given. So we're going to label on our picture all of the information that is provided, side lengths and our angles. Step 3 is write your equation. Step 4 is to solve and round appropriately. And step 5, this is somewhat new, is make sure your answer is going to address the question. And part of that is going to be making sure you are going to be putting in your units as well. So we'll talk about that too. All right, let's look at our first problem. I'm going to start off with my right triangle. And so then we've got find the angle of depression to the nearest degree. So angle of depression, remember, we're going to look straight across, forming that horizontal line, and then downward from that. So I'm going to call this X. From the top of a lighthouse that is going to be 275 feet above water. So our height is going to be that 275 feet. To a boat that is going to be offshore with a distance of 1,324 feet. All right, so now that we have everything labeled, like I said, I personally like to put my angle of elevation in here. So I'm going to move that X down here. And so now we just treat it as the rest of our trick. I'm going to start by circling my angle, labeling my opposite, the side that does not touch the angle, my hypotenuse, the side that is not touching my box, my right angle, and then my adjacent. From there, since I know nothing about the hypotenuse, I need to use my opposite, my adjacent. That is my tangent function. So we'll have tangent of my angle is going to be equal to my opposite over my adjacent. All right, so this right here is what we are going to be showing for our work. And then remember, when you are solving for X as an angle, all you are doing is you are going to switch these two. Okay, we're going to use what's called our inverse trig, our inverse tangent. And so that's going to be when you see that -1 up top. And in my parentheses, like you see here, I'm going to plug in that fraction. And it should be equal to that X. Okay, at this point, we need to plug this into our calculators. So I'm going to have that inverse tangent, and we're going to take that 275 divided by 1,324. Okay, and when I plug that in, I'm going to get something along the lines of, we'll say 11.7337. Okay, so key thing here is making sure that we are rounding to what they did ask. And so if I look back up here, I noticed that they did say the nearest degree, which is just going to be the nearest whole number. Okay, so here I'm going to look at that 7. And so because that is 5 or more, I'm going to round up. And so my final answer is going to be X is equal to 12 degrees. All right, now let's move on to number 2. Okay, once again, remember, it's going to be helpful as you're reading through this if you already have your right triangle drawn and you can just label it. I'm going to start there. So we have a 20-foot ladder is going to lean against a wall. And so that ladder is leaning against that wall. That is going to be this length here. That would be my ladder. And so that's where my 20 feet is going to go. And the base of the ladder is 8 feet from the base of the building. Okay, so if this right here is my building, then we want that ladder's base to be 8 feet away from it. They're asking, what is the angle of elevation for that ladder? So I'm solving for this angle here. So now we can go ahead and start solving. I'm going to mark my angle, I'll label my opposite, my hypotenuse, and my adjacent. From there, I notice that I do not have my opposite. So looking at that SOHCAHTOA, that's going to be my cosine. And so I'll have cosine of my angle, that x, is equal to the adjacent, so 8 over my hypotenuse, 20. Okay, so now I'm going to, since my x is what I'm solving for and it's inside my parentheses, I'm going to switch these two and use that inverse cosine of 8 divided by 20. Okay, at this point, this is what you're going to plug into your calculators. Remember, you shouldn't be plugging in that x equals. It should just be whatever comes after. So we have that inverse cosine of 8 divided by 20. Now, I will say this one does not tell me where to round. So I'm going to go ahead and I'll write a number down and I'll pick where we'll round. All right, let's go ahead and round to the nearest tenth. We've got, that would have one number after the decimal. So I need to look at the second number to determine what happens to that number after my decimal point. So looking at that second number, we've got that 2. Since it is less than 5, I am just going to go ahead and erase everything after my 4, and that will be my answer. Now, since this is an angle, I do want to put that degree symbol. And so this here would be my final answer. X is going to be 66.4 degrees. All right, now let's move into number 3. Okay, so once again, I'm going to start with my lovely right triangle. We have that Sage, who is 5 feet, oh, that's supposed to say tall, is flying a kite. All right, so here we have Sage. I'm going to draw a little stick person who's going to be 5 feet tall. The kite string is going to be 75 feet long. Okay, so when you're flying a kite, that's going to be my length here along that hypotenuse. Okay, so that's going to be 75 feet. And if the angle of elevation is going to be 35 degrees, we want to know how far above the ground is the kite. Okay, so here we had our angle of elevation was 35 degrees. So remember, that's us looking upwards, so it should be down there at the bottom. And I'm looking for the height of my kite. Okay, so here I'm going to look for this X here. That's going to be how tall it is. But the one thing to keep in mind is that, remember, Sage is already 5 feet off the ground. So whatever we find for my X, we need to add this 5 feet to it. Okay, so let's solve for our X first. I'm going to circle my angle, label my opposite, my hypotenuse, and my adjacent. Okay, so looking here, we have opposite and hypotenuse. That should be my sine. And we'll have 35 degrees in my parentheses equals to that opposite x over my hypotenuse 75. All right, unlike with the last two problems, here you do not want to just switch the angle and the x, the fraction, because that puts the x inside of the parentheses and therefore we can't separate it, okay? But since my x is a side length, it is in the fraction, what we can do is work through to break up that fraction. We can multiply by the denominator to both sides. And when I do that, I'm going to be left with 75 times that sine of 35 degrees is going to be equal to my x. Okay, to clarify on the right side here, these two are going to cancel out. Okay, and then whatever I get here, remember, we do want to add that 5 to it. So let's go ahead and take a second. Let's plug this into our calculator. We're going to have that 75 times my sine of 35 degrees. And that should give me roughly about, we'll say here, 43.018. So let's go ahead and round to the nearest whole number for this one, just switching it up. And I'm looking at the number after the decimal point, that's a 0. And so since that is less than 5, I'm just going to erase everything after my decimal point, and we'll use 43. Okay, and so then my key thing here, like I said, to get my actual final answer, I do need to make sure I am adding that 43 plus the height of Sage, that 5, to get 48 feet. Okay, make sure you have your units on the end. All right, moving on to number 4. Okay, I'm going to start with my right triangle once again. All right, so for this problem here, we have that a lifeguard is going to be sitting on a platform, so that should be at the highest point. And he's going to be looking down at a swimmer in the water. Okay, so here's my little lifeguard person down here, or up here, and then my swimmer can be down here. And they are telling us that if the lifeguard's line of sight is 8 feet above the ground, okay, so we're going to have 8 feet here for the height, and the angle of depression to the swimmer is going to be 18 degrees. So remember, when you're starting at that high point, you got to first look straight across and then downward from that to get that 18 degrees. What is the horizontal distance rounded to the nearest hundredth from the swimmer to the lifeguard? Okay, so horizontal is going to be that left to right. And so I'm going to put an X here for this length. That's what I'm going to try and find. All right, remember, I like to have my angle of elevation because it's going to be in my triangle. So I'm going to move that 18 degrees down here. And then we can start using our steps to solve. So I'm going to mark my angle. I'm going to label my opposite, my hypotenuse, and my adjacent. Okay, from there I can see that I'm going to be using my opposite and my adjacent. That's going to be that tangent function of 18 degrees is going to be equal to my opposite, that 8, divided by my adjacent, x. Okay, then working through and solving. Okay, I'm going to multiply both sides by my denominator as I kind of talked about in the previous one. And when you do that, you're going to get x times tangent of 18 degrees is going to be equal to that 8. Now, unlike in the previous problem, here my x is not isolated. I need to remove that tangent of 18 degrees and move it to the other side. So I am going to use my inverse operation. and we are going to divide. Okay, and so here you should be left with x is equal to that 8 divided by tangent of 18 degrees. Okay, and this here is what we're going to plug into our calculator. So here, give me a second. All right, so when we plug that in, we're going to get our x. I'm going to just give a few decimal places. We've got 24.62146. All right, so reading back into this problem here, we did have that we were asked to round to the nearest hundredth. And so with that being said, think about 100. You have 2 zeros, so I want 2 numbers after my decimal. So that means I need to look at the third one. Well, my third number after that decimal place is going to be a 1. And so since that is less than 5, we are not going to change our number. So I'm going to just erase everything. Oops, it's not erasing. So I'm going to erase here everything after that 2. And that will give me my answer. Just make sure that we include our units, which were our feet. All right. We have one final problem, saving the hardest for last, unfortunately. So here we have in the figure on the right, sorry, it's supposed to be on the left. I had moved it. The co-pilot in the airplane is flying at 8,000 feet over the ocean and sees an island. We are going to find PQ. Okay, so we're going to find this length here, which is going to be the width of our island. All right, this one's going to be a little challenging, but bear with me. Okay, so the first thing, since they do have a picture, the first thing I want to mention is, remember, we said that this whole unit is about right triangles. Okay, so in order to find PQ, I need to find some lengths that are going to be used in our right triangles. Well, currently I'm going to see here that I have a right triangle being formed with this entire line and that 8,000. Okay. But that doesn't really give me that PQ that I was looking for. So I'm going to squiggle through it. This is what I'm looking for. So what I do notice is I do have another right triangle here. I have a slightly smaller right triangle being formed up to that P. And if you notice here, if I start at the blue triangle and I find that length down here, I'm going to call that X. If I start by finding X, what I can do is I can subtract all of this pink length here all the way to that P, which I'll call Y, and I should be left with that PQ distance. So that's what we're going to do. Okay, so I'm going to start off with, we'll start with our X, and I'm going to notice up here that that 27 degrees is going to stop on that hypotenuse for that blue triangle I outlined. So that means that down here, this angle should be 27 degrees. Okay, and so I'm going to label, I'm marking that angle, my opposite, my hypotenuse, and my adjacent. Okay, so now that I see that, I can see I know nothing about that hypotenuse. The only trig function that will not use hypotenuse is going to be my tangent. So for me to find X, I'm going to use tangent of my theta, my angle, so 27 degrees, is going to be equal to my opposite, which we labeled as that 8,000, divided by my x, what I'm trying to find, that adjacent. Okay, and so now I want to solve for x. Now, I did remember now that I forgot to show you the trick that I had mentioned I was going to show you in this previous problem. So let's come up here and I'll show you the trick and then I'll apply it to this one. So the trick is when your x, what you're solving for, is in the denominator. So here and in the problem we're on, my x is in the denominator. What I can easily do to solve for x a real quick one-step way is to take that x and I can switch it with the trig function that I have on the left side. So here I can take my x in my denominator and I can move it where that tangent of 18 degrees is. And then once I switch that over there, I need to take that tangent of 18 degrees and I need to replace the denominator with it. Okay, so for here in the problem we are currently working on, if I apply that trick, I'm going to move my x over here to the left side. And once I do that, I'm going to have that 8,000 divided by whatever I replaced it with. So that tangent of 27 degrees. And that should give you your answer. Now, I will say I'm going to hold off on plugging this into a calculator and I'm going to plug in everything at once so that I don't have to round a million times and then have a rounding error in my answer. Okay, so we are going to, this should say find x. Okay, so we're going to take that, we'll pause there and let's move into our y and then we'll come back to it. All right, so to find my y, okay, I'm going to move that 39 degrees that I currently have as my angle of depression down here inside my triangle as my angle of elevation. And so now I can circle it and label my opposite, my hypotenuse, and my adjacent. Okay, you'll notice here once again we don't know my hypotenuse, so the only trig function that does not use hypotenuse will be our tangent. So we're going to use that tangent again, but this time of 39 degrees will be equal to my opposite, that 8,000, divided by my adjacent, which I called y. Okay, once again, using that quick trick here, I can take that denominator, my y, and I can move it to the left side of my equal sign. Then on the right side, I'll still have that 8,000 divided by, but this time I'm going to replace that tangent of 39 degrees where my y was. Okay, so to find that PQ, we want to start with the longest length, okay, and that's going to be that x. So we're going to take that 8,000 divided by a tangent of 27 degrees. And we are going to subtract the part of it that we don't want, which was all of that pink triangle's length. Okay, so I'm going to subtract that y, that 8,000 divided by my tangent of 39 degrees. And this right here is what I need to plug into my calculator to get my final answer. So give me 1 second. Let me plug this in. All right, so when I plugged it in, I got 5,821 point, okay, we got 706 is where I'll stop. Looking at this, if I want to round to the nearest, let's say 100th, okay, because this one doesn't specify, I'm going to look once again at that third number. And so here, the third number after my decimal is a 6. Since that is greater than 5, I need to take that and I'm going to round that 0 up to a 1. So here my final answer for PQ is going to be 5,821.71 feet.